We're given a quadratic in this question and then two straight lines, L1 and L2. L1 is normal to C at half 3. L2 is normal to C at the minimum point. That's going to be a vertical line. We'll get onto that later. But first up, we're asked to determine the equation of L1, giving our answer in this form. So to deal with this, we need to differentiate the quadratic, put a half in, because that will give us the gradient of this tangent, and then we'll take the negative reciprocal of that to get the gradient of the normal, because this is going to be 90 degrees. Okay, so dy by dx is 8x minus 10 when x is equal to a half. Dy by dx will be 4 minus 10, so minus 6. This is the tangent gradient. That means the normal gradient is going to be 1 over 6. And L1 is going to have equation, well, it's y minus y1, so y minus 3 is 1 over 6 x minus x1, so x minus a half. We could multiply it out to give it a sixth, or we can just deal with it right now, times through by 6. So 6y minus 18 is going to be x minus a half. We're asked to have a, b, and c as integers, so I'm going to times through by 2 again to get rid of that half. So 12y minus 36 is 2x minus 1, which means 2x minus 12y is going to, plus 35 is going to equal 0. That is the equation of our normal. Okay, so now we're told that the shaded region shown is bounded by C, L1, and L2. Determine the inequalities that define the shaded region, including its boundaries. Now, it's not that many marks, just make a note of that. There's a couple ways we can get this value here, the x value. Actually, the quickest is going to be just to set dy by dx equal to 0. That's going to give x is 10 over 8 or 5 over 4 or 1.25. Don't forget there is a function on your calculator that will also deal with this. If we put in a polynomial, then it finds the roots, of which there are none, so that's why we've got i's here, but then it will actually give the value of x for the minimum. So 1.25. That's another way to get it. You could complete the square. That is absolutely unnecessary, and it's just going to take a while. So because we have dy by dx, use that or your calculator. Okay, so this immediately gives us that it must be x is greater or equal to 1.25 or 5 over 4. I'll leave it as a fraction, I think. It's got to be to the right of L2. I won't put a box around it quite yet, actually. Now, we've also got to be above the quadratic, so we can say that 4y is going to be greater or equal to 4x squared minus 10x plus 7. Y has got to have so remember for the line itself, that's when it's equal to it, so it's got to be above it. That's where the greater or equal to comes in. And finally, it's got to be below L1. Now, originally we had L1 as this, so I could write it as y is going to be less than or equal to 1/6 x minus a half plus 3. And that would work. Maybe we could write it using this version just to make it a little bit neater. So you just have to be careful here, getting it the right, like everything the right way around. So what would happen if I had instead of equals less than or equal to, I've just got to make sure I'm not dividing through by a negative because that would change the sign there. And then less than or equal to here. When I minus it, actually it's going to become greater or equal to 0. So that would be an alternative. We could write 2x minus 12y plus 35 greater or equal to 0. But I personally think this one is absolutely fine. It doesn't say that you have to simplify them, but those three together are our inequalities that define the region. Just going to say one last little thing. Another way to work out which way the sign is going is that you can take this thing here and then you can pick a point and see if it's in the region or not. So let's look at 0, 0. Okay, if this one is in the like when I say in the region, I mean it's either going to be below the line or above the line. So is it below the line? Now, if 0, 0 works, then we're okay. And actually, if we put 0, 0 in, this would just cancel. We'd get 35, which is greater or equal to 0, which means that 0, 0 is in the region. Whereas if you put in something, a large value of y, for example, like, I don't know, 20, then we'd get, like, let's say x is 0, y is 20. Then now we'd get a large negative number here, which is not greater or equal to 0. So that's another reason why it's not in the region. It's just another way of deciding whether to go above or below the line.